Hi everyone. In this step, we have estimated the move that will help or killing the opponent. So here the estimated value has been done by using the hypothesis function of neural network. Sometimes there is the possibility of error in the estimated value. So for finding the best hypothesis, we should minimize the error by calculating the difference between training values and predicted values. So this is the training values output target function, and predicted function is got from this hypothesis function. For example, it may be a plus 82. So the difference between the plus 82 and 100 is the error of this particular training example B1. So the learning algorithm should incrementally refine the weights. So weights are given in this each and every term of the hypothesis function that should be refined to get error free training examples. So for that we can use least mean square algorithm. So that is used to adjust the weights, that means updating the weights a small amount in the direction, to reduce the error between this predicted output and the training, I mean actual output. So for this we are using the algorithm here with the number of iterations. So incrementally we have to refine the weights. Incrementally in the sense we have to use the number of iterations. So in the number of iterations we will calculate the error for each and every training sample. Then total error will be calculated. This is the actual output given from the table, and this is the predicted output of the learning system. Then here we are calculating the difference between the two outputs, and we are squaring up. Suppose the actual output is 100 and predicted output is 101, so we are getting the negative value. So actually error should not be mentioned in the negative value. That's why we are going to square it up. So when you are squaring this, it will come as a positive 1. So that's why we are using the squared up value here. For each board feature we have to update the weights, but because our hypothesis function is here v cap equal to w0 plus w1 x1 etc w6 x6. So here we are having w value weights for each and every features from x1 to x6. So we have to update the weight for all the w's from w0 to w6. So here for that we are having the formula. This is the new w updated value equal to this is old w value plus the learning rate, the iteration step. So when you are moving the iteration step, so we will use the all learning rate. It is used to uh, uh, determine the size of the weight update. So here the error is calculated in this place. Then it is multiplied with the respective samples, respective feature values. So here the learning rate will be mentioned in the form of 0.01 or 0.001. So it will used for updating the weights. So in this way we can reduce the difference between this actual output and predicted output. So here this is plus 1. Suppose sometimes actual value may be 100 minus the predicted value may be 125. So here the major difference between the actual output and predicted output, so it has to be decreased towards the 100. So for that we can use the least mean square algorithm to reduce the error. Thanks for watching.